Hello everyone and welcome to TLE Eliminators. This is Vibhaas. Um, Welcome to the stream, guys. Am I audible? How was the contest? Yes, Prince Raj. The problem was, I think, a standard algo question. A, B done. Nice. Okay. All right, everyone. We will get right into the questions now. Um, Govind Lauhar asks if we do code force, then we do not need to do lead code. See, extra practice never hurts, right? Yeah, we know that code force is slightly harder, but then lead code has different style of questions. It has more interview style of questions. So if you're preparing for interviews, then lead code is definitely good, right? Anyways, yeah, ABC done. Yeah, I also did ABC in the contest. D was, I guess, a hard algorithm, which, unless you know the algorithm, it's pretty hard to solve it. So yeah. I will discuss D. I'll just discuss the algorithm and rough idea about the algorithm, but mostly we'll talk about ABC today. All right. Now, before we get into the stream, as usual, if you haven't checked out TLE Eliminators yet, go check it out, right? Our self-paced courses are live and they're available on the website. So if you haven't checked it out, it's at tleliminators.com/courses, where our courses are divided into 4 different levels, and they give you an ordered and structured approach to competitive programming. So if you feel like you're not sure where you're in your CP journey, or you feel stuck, then or you feel like you don't have peers who help motivate you, so you should do check out the course because it has a progress tracking and leaderboard, so it feels competitive, right? It feels like your other peers are there who are doing it alongside you, so you get the motivation to do it. It also has 40 hours of recorded lectures, and the benefit of this is it covers all the major topics, so you know that you're not missing any topic by doing them, right? As well as practice problems, hints, and video solutions, as well as doubt support. So if you ever get stuck, there's doubt support by high-rated coders. So do check it out. Okay. I will talk about the, yes, we will talk about the, I will go through the algorithm roughly. I did have like GPT code it out, so we can have a look at that. But yes, um, let's get started. So problem A was pretty simple. Um, A and C are related, so we'll do A and C first, then we'll do B, and then we'll do D. Okay, so we'll do it in this order. So problem A, all right, problem A. Okay, what does the problem say? Earliest finish time for land and water rides. You're given two categories of theme park attractions, land rides and water rides, and each land ride starts at a particular time and it has a particular duration. Okay, similarly, each water ride starts at a particular time and has a particular duration. A tourist must experience exactly one ride from each category. So he must do one land ride and one water ride. And it can be in any order. It can be either land ride followed by a water ride or a water ride followed by a land ride. And you must note this, a ride must be started at its opening time or any later movement. So you can start the ride at its opening time or any time later than when it opens. Also, if a ride is started at time t, it finishes at time t plus duration. And once it finishes, you can board any other ride. Okay. So now you need to return the earliest possible time in which the tourist can finish both rides. So if you remember, he needs to finish one land ride and one water ride. So what is the earliest possible time he can do one land ride as well as one water ride? Okay. And here are some examples. This is the start time of two different land rides. The durations. There's one water ride and its start time as well as its duration, right? And so on are examples. Now pay attention to the constraints. The constraints say NM only goes up to 1000. Okay. NNM only goes up to 1000. IIT and Love, don't worry. I did not use GPT during the contest. Um, After the contest, I knew it was Moore's algorithm, so I told GPT to write Moore's algorithm. So I can show you the template of what Moore's algorithm looks like. So don't worry about that. I only solved ABC during the contest. Yeah. C and A are the exact same question except the constraints are changed. In A, the question has nm up to 100. In C, nm goes up to higher. Okay. So now for problem A, we just need to make one observation. Okay. First is nm is less than equal to 100. And the second is we need one land ride plus one water ride. Okay. So we don't know which land ride and which water ride will help us finish earliest. But we do know one thing. We can brute force through every pair of land ride and water ride. Okay. So this is going to be our idea. By seeing the small constraints, we will brute force through every pair of land ride and water ride. Okay. So that's the idea we get. Brute force every pair of land ride and water ride. Okay. So basically what that will look like is for every I from 0 to n and for every j from 0 to m. Okay. For j from 0 to n. And what we'll do, we'll try to pair up this land ride and this water ride and see which one finishes fastest. Okay. So how do we see, let's say when we can earliest finish this pair? Okay. So, um, so first we need to do either the land one or the water one, right? So we can find the ending time for the land ride versus the ending time for the water ride. Okay. So we can write end A. So this is the ending time for the land ride, and this will be simply um, the uh, the um the start time when we can do it earliest and the duration. Okay, so it will be the start time we can do it earliest as well as the duration of it. So also since we know that we need to do this particular pair of land ride and water ride, all we need to do is basically um, we can find the start time and the duration and add them so we get the ending time of the land ride as well as the ending time of the water ride. Okay, so we can have two ways. Either we did the land ride first, then the water ride, or we did the water ride first, then the land ride, right? So there are two ways to do it. So that's what we're trying to calculate here. So it will be basically, so the variables were named here land start time, land duration. That was too long to write. So I just named it LS and LD. So please note that LS means land start time, LD means land duration. Okay. Similarly, this means water start time and water duration. So we can write this as LS of I plus LD of I. And this we can write as WS of I plus WD of I. Okay. So this is the earliest we can end our land ride. Earliest do our land ride. Yeah. And this is the earliest we can do our water ride. Okay. Earliest we can do our water ride. Okay. And now if we want to do the land first and then the water, then basically it will be the max of either the ending time of B or it will be ending time of A plus the duration taken to do the second ride. So that duration is this. Okay. So this is the answer for how much is the minimum time it will take if we do the ith land ride followed by the jth water ride. Okay. And this is the answer for, and answer B will be to do it the opposite, to do the water ride first and then the land ride. Okay. So that will be something like this. Okay. So here LS and LD means this land ride start time, land ride duration. Similarly, water ride start time, water ride duration. And if you observe, this brute force is one of the ways you can solve the question. So obviously we're doing brute force. The formula you can write here in many ways, but this is the formula we're writing. And then our final answer. So we can have a final answer variable. Let's call it answer. And that answer will be initially will initialize to like infinity, right? We'll initially keep it infinity. And here this answer will be the minimum of answer, answer A, answer B. Okay. So I hope you got this. This is a very simple brute force approach. We're considering every pair of land right, water right, and we are saying land followed by water or water followed by land. So this is land followed by water. Answer A is land followed by water, and answer B is water followed by land. We're checking both the cases and we're taking minimum throughout all the possible pairs. Okay, is this understandable? So basically, what I'm saying is, um, we have to pick one land right plus one water right, right? So one land right plus one water right. And so we'll try all pairs, try all ij pairs. And there are two options. It's either land followed by water or water followed by land. So we're trying both those options also. Either land followed by water, or water followed by land. Okay. And for both the pairs, we're computing the answer. So these two are for land followed by water, and then these two are for water followed by land. And here this is just finding when the land one will end, and this is finding um when is the minimum time we can do the land followed by the water. This is when the water one will end, and this is when we can do the water followed by the land. Okay. Any doubts in this? Please ask, because maybe the equation might be a bit confusing for you. I'll try to explain where it comes from. If there are no doubts, I'll just move on to the next question. Problem C. Problem C is basically a harder version of this only, in which we cannot do brute force. Is everyone following this? Govind, I will answer general questions at the end of the stream. Okay, so right now we'll discuss all the problems first, and then at the end we'll discuss. Yeah, code for this. To be honest, in the contest, right, I just solved the harder version directly. So for this, I have not exactly written code. Um, although I can code it out live if you want that. It's the exact what I wrote here. You just implement this exact thing, it will pass. Kavish. Yeah. If you implement this exact thing, it's gonna pass. I'm pretty sure about that. For me, the harder version was also straightforward, so I just did that directly, and that's what I'll explain after this. Okay, so I hope this is understandable. It's basically just trying all the cases and trying these two. And for these two, you just need to think logically when we can earliest do land followed by water and when we can do water followed by land. Okay, now for problem C, and problem C is the exact same as problem A, but we need to solve it in O of n instead of O of n squared, right? So here we took n squared time, and in problem C, it's the same question, but here n goes up to 5 times 10 to the power 4. So we need to solve it in n log n or O of n. So the solution I did was O of n, and I'll explain it now. So the observation we need to make is that we do not need to check every pair. We do not need to check every pair. But basically what we need to check is, um, what we need to check is, so if we sort them by ending times, or how do I say this? The answer is going to be basically the earliest ending land um, land ride plus a later water ride. Okay, so it's either one land ride followed by a water ride. Okay, and the land ride, which is the first one, will be the one with this, which one ends the earliest. Okay, so if we are doing a land ride, obviously it's best that we do the one which ends the earliest, right? And which one will end the earliest? The one with the smallest value of ls of I plus ld of I. Okay, so it's either this one followed by a later water ride. Okay, is this one followed by a later water ride, or or it is the earliest ending water right, earliest ending water right, okay, followed by a later land right, okay, okay. So instead of checking all pairs, here we just need to check the earliest ending one for land plus the all the water rights. Similarly, here we need to check the earliest ending one for water and all the later land rights. Okay. So basically, instead of big O of n times n, it becomes it becomes big O of n plus n. Okay. Because the earliest ending one, we can find it in O of n. And similarly, we can find this in O of n. And to check these also takes O of n and O of m respectively. Right. So how do we code this up? So basically, we need to know which one is the earliest ending land right? So basically, we just need the smallest value of, here we use two variables nday and nb, right? So we just need the smallest value of nday and nb first, okay? So our algo will be something like this. Find smallest value of um, the start time plus the duration, so LD, okay? And we'll call this nday. So this is the smallest ending time for a land right, okay? Similarly, we'll find the smallest value of water right plus, so the start of the water right plus the duration of the water right. So this is the smallest ending time of any water right, okay? So we're finding the one which ends the earliest for both land and water, okay? So we just found this, and this we can do with a simple for loop, right? We can set these end a and b to infinity, and we can go through each I from 0 to n over here, 0 to m over here, and we can find which one ends the earliest in both land and water, okay? Now what we need to do is we need to go through the water, and we need to um now we need to figure out that for every water ride followed by this land ride, right? For every water ride which can come after this. So after this, one water ride will come, right? When is the earliest that can end? Similarly, for every land ride, when is the earliest that can end? Okay, so after this, if it starts, when can it end the earliest? Fine. So that's basically going to be right. So let's do land followed by water first. So land followed by water. Okay, so land followed by water. So that's basically something following end day. Okay. So basically there'll be two options. Either we can do it immediately after end day, right? So the water duration, either we do it immediately after end day if its opening time has already started. Otherwise, if its opening time has not started yet, then we can only do it when it start and when its opening time happens until it ends. Okay. So it will be max of this. Okay. And we have to take minimum over all I. Minimum over all I of this value. Okay. Minimum over all I of this value. Similarly, if we have water followed by land, then it's very similar. We just need to take, so first the water ride happened. So that will be end B amount of time. Then we're going to do this land ride. So its duration is I, assume we started now. Otherwise, if it's not started already, it will start later, right? So that will be ls of I plus ld of I. ls of I plus ld of I. Okay. And in this also, this value over all I will take minimum. Okay, minimum over all I. Finally, in both of these cases, we'll see which one is minimum and print the answer. Okay. So the final step will be print the answer for the minimum over both of these cases. Final step. Print minimum over both the cases. Over both the cases. So the only thing we have to observe over here, the logic is mostly the same, that we don't need to do an n square code because the only the earliest ending land ride and the earliest ending water right should be cared for. Otherwise, why would we do a later land right, right? Because if we can do an earlier land right and then do whichever water right we wanted to do, that will obviously be better. Similarly for the other case. We are on C right now. Yeah. A we discussed. A was the brute force approach for this problem. C is the slightly optimized approach for this problem. Both are, I think, simple only. So actually, while solving A itself, I had gotten the optimized approach. So to A, I have submitted directly the optimized version. Yeah. Although, if you want, you can go ahead for practice sake and implement the brute force version as well. You can mostly directly implement the pseudocode. It should pass. Okay. Right. So let's have a look at the code for how the optimized version goes. Uh, so we have N and M over here. Here we're finding which landline earns the earliest and which water right ends the earliest. That'll be stored in end A and end B respectively. Once we have found both of those, we're going to find the answer for a land right followed by a water right, as well as the water right followed by the land right. And for each possible water right, we are seeing after the land right can it be taken, and we're updating that, and we're finding minimum across all of them. Similarly, for each possible land right following the water right, we're taking minimum across of that. Finally, when both of the cases are done, land followed by water and water followed by land, we print the minimum. Yes, D is Moore's algorithm, yes. Sec3, I'm not sure if that, yeah, I think there is some Sec3 approach, but it's very complicated. Can I use Sec3 in question 3? Why in question 3? I do not see how you can use Sec3 in question 3. Question 3 is the one we were just discussing right now, right? I think you mean question 4. I'm not sure. This is for the user certain. I don't understand how you intend to use Sec3 in question 3. Can you elaborate? For watermelon tomatoes, yeah, it is Moore's algorithm. And there is maybe some Sec3 solution, but that seems too complicated. Okay. Now that we have covered problem A and C, um, we're moving on to problem B. Okay. Problem B is again a pretty standard problem. I feel like today's problems were all very direct algorithm questions. So A and C were also pretty direct, and B was also very direct, and D was, although it was a hard question from a unknown, relatively less known topic, it was also somewhat of a direct question. If you struggle in problem A or C, then you should try level 1 or level 2 of the course. All right. So just informing in case you're thinking about the course, yeah, you should try level 1 or level 2 if you are stuck in problem A or C. For problem B, the topics are covered in level 3, so you can solve it using binary search or two pointers. Two pointers is better because the complexity will be better, but obviously you can solve it with binary search as well. Okay, so let's move on to problem B. You are given an integer array nums and an integer k. The array is considered balanced if its maximum element is at most k times the minimum element. Okay, you may remove any number of elements from nums without making it empty. Return the minimum number of elements to remove so that the remaining array is balanced. Okay. Note that an array of size 1 is considered balanced as its maximum and minimum are equal, and this condition will always hold true, right? So this is just an additional note. So basically, we need to figure out how many are the minimum number of elements to remove so that the array becomes balanced. Fine. Okay. So let us see how we can approach the problem. Okay. First of all, let us sort the values. Okay. Why are we sorting the values? Because first the constraint allows it and it will not change our answer, right? As you can see, the constraint goes up to 10 to the power 5. So n log n solutions are perfectly fine. So that's why initially we're just going to sort the whole array. Okay, so sort the values. It won't change our answer, of course, right? So for example, we have an array like 1, 1, 2, 3, 4, 5, 6, and let's say k equals 2 or k equals 3. Fine. So if we are at this 1 in the array, if we are at a 1 value, then the allowed elements are from 1 to 3, right? So like assume that 1 is the minimum of our final array. Like after doing the deletions, 1 is the minimum element. Then the valid elements which can be there are from 1 to 3. So we'll have to delete the last 3 elements. Okay, we'll have to delete the last 3 elements because they are more than 3 times of the minimum. Okay. Now what we're going to do, assume that 1 is not the minimum and 2 is the minimum. Okay, now assume that 2 is the minimum. Okay, if 2 is the minimum, then what is 2 times 3? So 2 times 3 is 6. Okay, so we don't need to delete any elements here. Nothing to delete, nothing to delete. If there was a 7, then we would have to delete it, right? So for example, let me just add a 7 over here. So if there was 7, we would have to delete this. And also for 2 to become the minimum, we'll have to delete everything smaller than 2. Okay, so we'll have to delete everything smaller than 2. Okay, so what approach should we have here? Okay, so assume after sorting, assume that element a of I, that element a of I is the minimum. Okay, is the minimum in the array, in the final array. Okay, so that means, so that already means that all elements less than a of I should be deleted, right? Should be deleted. And how many elements will be there less than a of I? That's pretty simple. That's simply I elements, right? I elements. So if our pointer is at some position I, we can say that the previous I elements should be deleted. Okay, deleted. So zero based indexing here. The I elements should be deleted. Now what about the elements which are larger than k times a of I? Okay. So what about elements larger than k times a of I? Elements larger than k times a of I. So now what do we need to do? We basically need to find where does k times a of I occur in our array. Okay, we need to find where does k times a of I occur in our array. Okay, for example, here k times a of I occurs here, right? 2 times 3 occurs at 6. And even if the number does not occur, we just basically need like a lower bound, right? We need a lower bound. So any number which is, sorry, not a lower bound, we basically need a number less than or equal to, right? So not exactly lower bound, but we need a number which is less than or equal to our target. So we can find this 5 is the element which is less than or equal to our target. Yeah, so we can say that all these elements are safe and the elements ahead of it are the ones which should be deleted, right? So we can do it one way is simply binary search. So method one, um, for all possible, for all possible I, for all possible I from 0 to n minus 1, for all possible I from 0 to n minus 1, we're going to, so the minimum is taken as a of I, right? Minimum is a of I. Maximum will then be k times a of I. We need to binary search the point which is just less than or equal to this. So in C++, we can write that as upper bound minus 1. Okay, we can write that as upper bound minus 1. So we can write the pointer j equals upper bound of maximum in that array minus 1. So minus minus, it's a pointer, so minus minus. And this is the j. Now, how many elements are there after j till n? And we can write that simply as n minus j. Okay, so we need to delete I plus n minus j elements. Okay, so if we do it this way in binary search way, we need to try every I, we assume that A of I is the minimum value, then the maximum value allowed will be k times A of I. So we find how many elements are there which are less than equal to k times AI by using upper bound or maximum minus minus. So this will find us the last valid element. Now we have to delete I plus n minus j elements, the I elements before our A of I and the n minus j elements after our A of j. Okay, right. So this is how to solve problem B using binary search. But this code is going to be n log n, right? So the sorting is n log n, the sorting is n log n, plus this method of binary search using lower bound is also n log n. So the overall complexity is n log n. Now, because the sorting is n log n, we won't be able to make it better than n log n, but there's a neater way to do this, and that is using two pointers. So if our array was already sorted, this would improve our solution from big O of n log n to big O of n. Okay. So the actual code will be big O of n log n plus n. So this will be sorting, and this will be the two pointers. Okay. And what is the two pointers method? So if you have not studied two pointers method, go check it out. It's a very crucial method for competitive programming. It's there in TLE level 3 as well as other YouTube videos online. Okay. And the idea is basically, since A of I is increasing, A of I is increasing, right? That means K times A of I is also increasing. K times A of I is also increasing. And what does that mean? That means value of J is also increasing. Value of J is also always increasing. Okay. It will either increase or stay the same. Okay. So value of J is always increasing or staying same for every I. For every I. So we can use the two pointers method. Use the two pointers method. Two pointers method. So this is called amortized time complexity analysis, right? So the two pointer method is a famous example of amortized time complexity analysis. At first, if you use naive time complexity, it seems like it's big O of n squared, but actually it's only big O of n. And the way we do it is we have a j pointer set to 0, okay? Then for every value of minimum, so every value of I from 0 to n minus 1, I less than n, I plus plus, right? We are going to increase our j pointer until it is, so while j plus 1 is less than n, and a of j plus 1 is less than or equal to uh, a of I times k. Okay, so we're going to do this and we'll increase our j pointer. Okay, we're increasing our j pointer till this last point manually. Basically, if this is our I, and if our j was somewhere here, then we'll manually increase our j over here. Okay, till our j reaches there. And basically, what we're going to do is now we can update our answer the same way. So answer will be the minimum value of answer plus I plus n minus 1 minus j. Okay. So similar to the binary search approach, we just have to increase. So this is the number of elements to delete before I, and this is the number of elements after j. So delete after j. Okay. Or yeah, actually here also it should be n minus 1 minus j. Sorry about that. In the binary search as well, I think. This is going to be n minus 1 minus j. Yeah. Okay. And that's all. So while this at a first glance it might seem like n square code, if you're not familiar with two pointers, you can show that this code is actually just big O of n. And the reason is j pointer is always increasing, so I pointer is always increasing. So at most it will cover a distance of n, right? So this will be also O of n by two pointers. Okay. And the code is very small. So let's have a look at the code. First we sort the vector, then let n be the size of the vector. Our answer variable is set to n minus 1 initially because we can always delete everything except 1. So this is the maximum possible value of answer at j is set to 0. Okay. So the reason this pointer approach works is because j is being a global variable, right? So it will never be decreased, it will only be increased. Okay. So here I goes from 0 to n. We increase our j pointer until it reaches k times v of I, right? So while j plus 1 is less than n, If v of j plus 1 is less than equal to k times v of I, we increase the j pointer, we update our answer, and finally when the whole loop is done, we can return our answer. Okay. Yeah, j is pointing to the last element, which is less than or equal to k times a of I. Okay. So let me just write that down. In our method, j pointing to last element, last index, such that a of j is less than or equal to a of I times k. Okay. So for example, if we have an array which is like 1, 1, 2, 2, 3, 4, 5, 6, 8, 9, 10, 13, 15. Okay, we have this array. We have k equals 4. And if our pointer is at, let's say, 2, for example, let's say I is over here, then j will go up till, so it's 2. 2 times 4 is 8. So j will point here. Okay, j will be here, right? And then when our I moves forward, I will move forward. Nothing will happen to j. But if I moves forward again, now j will start incrementing. J will start incrementing, and it will go up to 12, right? So at most it will go up to 3 times 4. So it will go up to 10 over here. So it will not increase more because 13 is greater than 12. So it will stop here. Okay, so this will be where our j points when our I is over here. Unleash the power. I hope you understood how this works. Okay, so if you have trouble understanding this, you should learn two pointers. It's a very standard algorithm, used almost everywhere. There are many YouTube videos available on the internet, as well as it's there in TLE level 3, which is discussed in detail. Itne hard contest. To be honest, today's contest was very easy. At least ABC was very easy, like very very easy. There was no concept at all. To be honest, it was all very, like, A and C were pretty much direct questions. D was just two pointers. Uh, I'm not sure how so many people submit. Definitely, see, nowadays we all know that with the rise of large language models, there is a lot of cheating these days. But obviously, that's not very good. And usually, when the ranks come out after 5 days, most of them get, the ones who cheated will definitely get removed. Like some people who are at the top already, I think, got removed, right? Like 5 minutes ago, I could see many names, but they are already missing. So, yeah. Problem D was decently difficult. It's a topic which usually you do not learn until you're like candidate master or above. Even like my max was candidate master on CF, but I've still not learned that topic because I never encountered it. So let's move on to problem D. Okay. If there are any doubts in ABC, ask right now. Otherwise, we're moving on to problem D. And at the end of the session, we will have some general doubts. Yeah, there are a lot of Indians doing lead code. Yes, it's mostly because in placement time the questions are very much lead code or CP style, right? Huh. Raghav, topic name for which one? D. So the topic for D is Moore's algorithm. And to be honest, if you're only learning for interviews, I don't think you should learn this because I don't think any interview is going to be asking you Moore's algorithm. At least hopefully not. Okay. So we will I do not know much about this topic. So, and this code is also not by me. I asked GPT to write code for Moore's algorithm, and I've kind of read it a little bit. So I won't be going much in depth. I will just be explaining very briefly and moving on. Okay. Okay. So let's read the question. Threshold majority queues. You're given an integer array of length n and an array queries where queries equals li, ri, and threshold. Um, I also solved only three questions, by the way. In the contest, I could solve three questions. The fourth question was Moore's algorithm, which is a very rare topic, I think. Okay. So you're given an integer array where their queries from LR and threshold return an array of integers where answer phi is equal to the element in the subarray that appears at least threshold number of times and the element with highest frequency. Okay, we have to select the element with highest frequency. In case there are several with the same highest frequency, we have to select the smallest element. Okay. So what is the question basically asking? It's saying we're given an array, given an array. Now we have to process queries, process queries, and the queries have to be of the form li, ri, and threshold. Okay, so this is the query form. Now what do we have to do? In the subarray, so what do we have to answer for each query? We have to say in the subarray, a of li till ri, we basically need to find the mode. Okay, most frequently occurring element. If you have studied statistics, you would know it's called mean, median, mode, right? So there are these three measures. In that, mode means the most frequently occurring element. Okay, the most frequently highest frequency element. So that is the mode. So we need to find the mode. Find the mode. Okay. If there are several modes, sometimes many elements can have the highest frequency, right? Many elements can have the highest frequency, so we need to choose the smallest. Okay. So find the mode. Smallest in case of type. In case of type. Right? And we need to basically return that, but we need to make sure that at least threshold number of times. Okay, so we need to check, and if frequency of the mode, frequency of mode is less than the threshold, is less than threshold, answer is -1. Answer to the query is -1. Else the answer is frequency. Else answer to this query is frequency. Answer is frequency. Sorry, not frequency, it's the mode, sorry. It's the smallest mode. Smallest mode, right? So that is the answer. So this is basically what the problem is asking. Given an array, we need to process these kinds of queries for its subarrays. And as you can see, the constraints are pretty strong. The constraints are n goes up to 10 to the power 4, right? N goes up to 10 to the power 4. And the number of queries also goes up to 10 to the power 5 times 10 to the power 4. Okay. And because of this, this like basically ensures that big O of n square solutions do not pass. Okay. Big O of n square does not pass. All right. So that's what this is going to ensure. So now you will need some experience with what is called Moore's algorithm. Okay. So I apologize if it's lagging. The internet connection isn't the best at my college. Yeah. Yes, Pratik, you're correct. You do need to do exactly that. That is in fact called Moore's algorithm. Okay. So the topic over here is Moore's algorithm. I'm not even sure if this is covered in TLE course. I don't think it is covered in TLE's course, but yeah. So basically here the um, idea is for each query, sort by this specific value, which is L by root n, comma R. So each query is Li Ri, right? So we have to sort each query by L by root n, comma R. Like this is a pair. And why are we doing this? Basically, this is making sure that the L values are in buckets. L values are in square root size buckets. Square root size buckets. So we're processing the queries in a very specific order, which will help us lower the time complexity. Okay. So let me just draw out the array. By the way, if my explanation is not very good, it's because, to be honest, I also did not know this algorithm that well. Just right now, I read up on it. Okay. So apologies if my explanation is not good. I will show you the link for where you can learn more about this. Okay. So the idea is, so it's a textbook kind of algorithm. It's not much to explain or like invent during the contest. Whether if you knew it, you solved it. If you didn't know it, you couldn't solve it. Okay. It was that type of question. So now, as we know, the queries are for different subarrays, right? So one query can start here and end here. So this is the L value, this is the R value. Similarly, one query can start here and end here, right? And these are the different Li, Ri for our queries. So let me just draw some queries so that we can understand what this bucket type of thing is doing over here. So, so let's say these are some queries. Okay, so you can see the left and right points for each query. Fine. Okay. So now what Moore's algorithm does is basically it sorts by L divided by root n, right? So what does that mean? Let's say n was 10 to the power 4, right? N is 10 to the power 4, that is the max value. So root n is 100, right? Root n is 100. So every 100 elements, let's say this is the first 100 elements. So this is the first 100 elements. Then let's say this is the next 100 elements. Then this is the next 100 elements, and so on, right? So every 100 elements are being divided into different buckets. So basically for this bucket, all the L values of this bucket will process first. Then all the L values in this bucket will process first. Then all the L values in this bucket, then all the L values in this bucket. Okay. And what we are going to do is basically um, for every LR, such that LR is in this bucket, right? Such that um, L is in this bucket, L is in this bucket. We have sorted it according to L divided by root n, comma R, right? So L divided by root n in this bucket will be 0. L divided by root n in this bucket will be 1. L divided by root n in this bucket will be 2, as you can see, right? And for everything which starts over here, L divided by root n will be 3. So basically what's happening is first all the R values of this bucket are being processed, then all the R values of this bucket, then all the R values of this bucket, then all the R values of this bucket. Okay. And the very interesting like mathematical property emerges from this. Very interesting mathematical property emerges from this is that if we have the first bucket like this, okay, the length of the first bucket is simply square root size, right? The length of the first bucket is simply square root size. And let's say our current L value is over here and our current R value is over here, okay? So then since L and R are sorted in this bucket, all L and R are, all the R are sorted. So if we go from query LR to query L dash R dash, how much does the R pointer move? Okay, how much does the R pointer move? Well, the R pointer can move some distance forward, right? And how much will the L pointer move? The L pointer can go anywhere here. The L dash can be before or the L dash can be after. So that there's no constraint, but we do know that L dash will be also in this bucket itself, right? So how much will L dash move? L dash moves at most root n, at most root n. So distance between L and L dash is at most root n. And also distance between R and R dash, since we are processing in this bucket and R dash keeps increasing, right? So it's something like 2 pointers almost, that the amortized time complexity to move across all these queries from R to R dash, then to R double dash, then to R triple dash. So these are basically the next query which we get in the sequence. And L will keep moving around in here while R will keep increasing in here. So basically the amortized time complexity for this is the amortized time complexity for all the moves between L and R will be n root n. Okay, so all the moves between these L and R will be n root n amortized time complexity. Okay. Yeah. So the algorithm is Moore's algorithm. Let me just note it down over here. Moore's algorithm. This algorithm is called Moore's algorithm. Okay. You can Google it. It'll be readily available on Google as well. Okay. So basically what I'm saying is as long as you restrict your pointer, L pointer, to move in a root n bucket and you sort the R pointers in this way, you can prove using some kind of heavy mathematics that the total time complexity for this will be n root n to move the pointer like this. Okay. Now, one more thing, while moving the pointer, how to keep track of how many elements are there. So basically what we're going to do is we're going to use a map to keep track of how many elements are there. So basically, um, while moving pointers, we'll have a map to keep track for every element, for every element, what is the frequency? Okay, what is the frequency? Fine. So that way, when we move our pointer to the left or to the right, all we need to do is basically, if our pointer was at some point here and we moved it to the right by one step, then this is our R and this is our R dash. Then what we have to do is basically map of this number at this new R, right? And we have to do plus plus. Similarly, if our pointer moved to the left, then we can do map of nums of L minus minus. So that's what when we move to the left or right, move left or right to reach our destination. Okay. Now, what if multiple elements have the same maximum? So in that case, we just need to keep track of the minimum as well. So we can use another set for that. Okay. I will also show you this blog. So if you Google Moore's algorithm, you get this blog, which is pretty good. I mean, it has a simple explanation. And also USACO's guide has a blog. Uh, yeah, USACO's guide, CP algorithms, all these places have different guides to Moore's algorithm. And so in the square root decomposition topic, which comes under pretty hard topics, platinum, um, they discuss Moore's algorithm here. And there are some resources over here which you can check out to learn this exactly. You can't learn it, I think, in one session right now. You will need to read it. So they explain how to maintain the blocks. It is actually not very hard. The implementation is not hard, but understanding the concept is a bit hard. Also this blog, so this blog is there at, if you go to USACO's guide, the first link, it has the exact same problem. So it says how to solve the given problem in which we need to get the mode number, right? Given an array, we query q times. Each time we want to get the mode of the subarray. Okay. And they describe a solution in n square root n log n plus q log q, right? And see, this is how we sort the elements. So to sort the elements, we need to sort them according to the value of L divided by root n comma R. So this is the comparison function used during the sorting. Okay. So let me have a quick run through the code. So this is not my code. But since this was standard algorithm, GPT is pretty good with standard algorithms. What was my finish time for this contest? I solved only A, B, C, and I started 10 minutes late. I think I finished A, B, C in like 20 minutes, so like total 30 minutes. And then D I could not do. Let me just have a look. Yeah. So total 31 minutes to solve this contest. A, B, C. Although I did start 10 minutes late, so you can say that ABC took me like 20 minutes and then I did not do question 4. This contest was hard. I would not say it's hard. I would say it used more standard topics, especially ABC. So if your standard topics are weak, then it would have felt hard. If you are good at like ad hoc problems and you're not good at standard problems, then this contest would have felt hard. And if you're feeling this contest would hard, you should learn more standard topics like two pointers, brute force, greedy, and the fourth question was also a textbook algorithm, Moore's algorithm. But yeah, fourth question you will not expect in interviews. So if you are practicing Leetcode to do interviews, then don't expect to see it. Okay, so just a very briefing about the code. This thing is not necessary. You can use a map instead of this. That will just give you extra login. This is to remove the login. So what we're doing is since the numbers are from 1 to 10 to the power 9, but the total number of numbers is only 10 to the power 4. It's just compressing the numbers between 1 and 10 to the power 4. Why is it that? Because then we use just hash table, a simple hash table, and that will run O of 1, right? If we want to use a map, it will be log n extra during our Mohs algorithm. So you can ignore this part as well. This is just a simple compressing the numbers. Okay. If you're expecting to solve Mohs algorithm, I think you should understand what compression means. So yeah. Okay. So now what we are doing is we are going to sort our queries. So we are first storing our queries like this. We are sorting them by the A of L divided by S and B of L divided by S, right? So that's how we're comparing two queries. We're sorting them by L divided by root n, where S over here is root n, as you can see. S is defined to be square root of n. Okay. So we are sorting them according to Mohs algorithms technique. Then what is add and remove? Add and remove simply means that when we move our pointer one step front, if we move our pointer from R to R plus 1, we are adding the new element. Similarly, if we move our pointer L one step back, that means we're removing the previous element. And why are there two special functions for add and remove? That's simple. That's because we're also maintaining maps, right? We're maintaining a maps for how much counts are there for each element, as well as which one is the maximum element. So that's why we have a special function called add and remove. You can obviously directly implement this into Mohs, but here GPT made two special functions called add and remove. Okay, so you can later go through this code if you want. Yeah, Mohs voting might give you wrong answer. Mohs voting, because Mohs voting only works when the mode is at least n by 2 frequency. Look, if you handle with hash set if less than n by 2, you see if you handle by hash set less than n by 2, either you're handling incorrectly or it'll TLE. Anyways, now what do we do in Mohs algorithm? So now there's nothing. We just need to process each query. Since the queries are already sorted in that special order, Mohs algorithm order, we can simply just move our L pointer and R pointer where they need to be. So we're adding and removing as required to move L and R to the correct position. Once it is moved to the correct position, we are simply finding the best value. We're finding which mode is the best value, and we're printing it out. If the mode does not have enough frequency, we're giving the query answer -1. Okay. So if the mode has enough frequency, so best frequency is towards the frequency, then we're giving that answer. Otherwise, we're giving -1. Okay, and we're returning that. Fine. So that is the code of Mohs algorithm. If you want to learn more, you can check out either USACO guide and or the implementation of Mohs algorithm or CP algorithms. Although if you're less than candidate master on CF, I would not recommend learning this. Yeah, yeah, Vinith. If you use a hash map to merge in segment trees, then each node of your segment tree will store up to n elements. So then it will become n square log n instead of n log n. Okay, so now we can take general doubts. I think that is how much I can explain Mohs algorithm. I didn't solve it myself, so I can't tell you much in detail than that. Um, I've also never used Mohs algorithm in a contest before. This was the first time, but I've heard of it. I've definitely heard of it. Okay, general doubts. How to upskill after a contest? Because I wasn't able to solve ABC, although I was close to the observations. Okay, so for this, I can just tell you, if in today's contest you are not able to solve, you need to focus on fundamentals. Okay, focus on fundamentals, especially in today's contest. What are the topics used? Um, problem A was brute force, right? Problem A was brute force, and problem B was either binary search or two pointers, right? They were all very standard questions from these topics: binary search and two pointers. And what was problem C? As you can see, even I took only 20 minutes for ABC. I needed only 20 minutes for ABC. Um, and problem C was roughly, it was just a basic greedy idea, like observation and greedy to improve problem A. Observation slash greedy. Okay, so A and C were pretty related, so that's why I've written it like this. D was Moore's algorithm. Very rare topic, very rare. Not recommended for below expert, I would say. Like even for expert, it won't be much use for you. For below expert. Okay. So if you struggle with today's contest, you should definitely revise your basic concepts like brute force and two pointers, binary search. How to upskill? So see, now that you know that these questions you had almost solved without seeing my implementation, like you might have seen my explanation and somewhat the implementation, go implement it by yourself and practice similar questions on the same topics. So practice two pointers, binary search, brute force. Okay. Sir, coding में मन नहीं लगता. See, that's up to you, right? Like no one external can put your mind in coding. All I can say is if you think of it in the right way, not just to get a job, but you think of it in the essence of what we are doing here, um, then you will find coding beautiful for its own sake, right? Because all this heavy optimization which we do, it involves a lot of cleverness, right? And you have to learn how to appreciate and have fun with that cleverness. Okay, what is needed to reach expert on CF? Uh, so in expert on CF, you need to know all the basic topics, prefix sums, bit manipulation, um, and then here binary search, number theory, combinatorics, greedy, hashing, two pointers, DP, and graphs. So all these topics you should know. Which ones did I list? I said binary search, combinatorics, number theory, two pointers, dynamic programming, graphs, prefix sums, stacks, and queues, right? So these are like the most core topics in CP, which are used up to like even CM also. You must know those topics. Once you have those topics down roughly, you can do like VCs and practice. Okay. Okay, you say that you already know the topics, but you need greedy proofs. See, greedy proofs you can only get by practice, right? You must do more greedy problems. It is very much based on pattern matching and IQ. So the way to solve and learn that is to do more practice. If you have been doing LeetCode for 2 years and you could not even do the first problem in this contest, then I would think that um, either you have not done very much, right? Either you have not done very much, or you have not been doing the topics which you were supposed to be doing, I'd say. Um, so in that case, I definitely think you should try out TLE's course, right? Because all the topics are there in a very structured manner. Um, I would say to make your fundamentals strong. This is my advice for Govind. What are the rating range of the easiest 6-7 questions of ICPC regionals? 6-7 is a wide range, but I think the first question can start up to like 1,000. The seventh question can go up to 2,200 roughly. So yeah, it's like 1,000 and then 1,200, 1,500, 1,800, 2,000, 2,200, like that. It starts increasing pretty quickly. This is for Plomo. Okay. My OAs are going to is going to start next month. How are OA questions? I'm not sure because my OAs also have not started, right? So I've just gone to third year, so I'm not very sure. But I can tell you that you should do practice lead code, especially all the basic concepts, because even if not in OAs, in the interviews, they will usually ask you standard topics only. They will not ask you some rare constructive problem. So I would suggest lead code first, code forces also, but secondary. But yeah, not the easy questions on Leetcode because otherwise you will feel pretty weird. You have done code forces. Is that why you can do any problems? To be honest, true. But the thing in code forces is they will give you more math and more constructive like problems. So as you can see, I could not do the fourth problem today. People who are doing lead code from a very long time and who have done almost all lead code hards, they would be able to do fourth problem because Moore's algorithm is like a textbook algorithm, not something which you come up with on a contest. Yeah, see, if you had a lot of time, if you have a lot of time, like 2 years, then you should start with code forces. Otherwise, you should give more focus to lead code if you just have like 1 or 2 months. Does Rubrik ask CP in coding round? I'm not sure, but most companies do, so I would assume yeah. I'm in which year? I just started third year. I just started third year, yeah. If your interviews are in like 1st December and all, then yeah, you should do both code forces and lead code. Don't don't compromise. Code forces helps you a lot in developing your thinking. Like lead code helps you in learning more theoretical aspects, I would say. Which college? My college is Triple IT Kottayam. It's a Triple IT in Kerala. If you're interested, like in my profile, you can check it out on the TLE website. Yes, I'm in third year, yes. Why would you stop CP when you're going closer to placement season? I would say you should make sure that your CP is at a like does not get rusty, right? I don't understand your question, IIT and Love or whatever your name is. Um, you should definitely have like you should definitely make sure that your level is maintained during OA season, right? Raghav, don't worry about that. Everyone has their own capability, right? Vineet Tiwari. So to be honest, I don't think you should skip Div 2s because if you skip Div 2s and reach expert, then you will drop in expert, right? If you feel like you're actually bad at Div 2s and you reach expert, then you're going to drop anyways, right? So I don't think it's good to be afraid of some particular type of division or something. Um, what my advice is, do Div 3s and maybe for a month do VCs, you can do VCs of Div 2s, right? So once you get comfortable in virtual contests, then you can start doing it in real life. Any resources for logic building? Code forces. That's the best resource for logic building. The practice problems over there. They require a lot of logic. Yeah. Um, that's what I can say mostly. Okay, guys, any other questions? Okay, so you're in fourth year and you are doing lead code, right? So what I suggest is make sure all your topics are down, right? Just make a mental map. These are the main topics on the Tele website, and those are the main topics which are usually asked anytime you go into interview or anything. So especially in interviews, DPs, graphs, I've seen a lot. DPs and graph questions, binary search as well. So those things you should definitely have down. And if you're going to a specific company, you can see what exactly that company asked and practice that, right? Don't you get annoyed because of massive cheating in CF? Yes, yes. Obviously I get annoyed. Like I was getting very annoyed last year, but see what can you do now? I have kind of given up on that. Um, the thing is until the placements do not start judging by some other measure, till the placements keep judging by the CP measure, I feel like the cheating will continue. So there is nothing much we can do about that except maybe help report cheaters if we find any of them, as well as most of the contests now platforms have plague checks nowadays. Like LeetCode has a 5 day gap, I think, for plague checks. Code Forces after every 1 or 2 months it does a rollback and the ratings get updated. So cheaters do get removed after some time, most of the time. I don't think you should get demotivated by that. It just should motivate you to work harder, as a lot of people are honest as well. Even if there are 2,000, 3,000 cheaters, the rest 20, 30,000 people are participating honestly, right? And you can be one of the honest ones. How do you manage CP with CTFs? To be honest, um, I do CTFs as a very hobby kind of thing. I have done only like 5, 6 CTFs. So, but yeah, I don't know. I felt very natural in CTFs, so I don't think you should take advice from me. Um, Plomo, you don't need to worry about that. It's it's a cyber security type of competition in which you do like CTFs are basically competitions where you need to use cyber security skills like cryptography, steganography, and stuff. Yeah, I'm not the best person to advise on that since that's not my main field. Govind, you can find my profile on the TLE website. Rohit says, I've been giving both Div 3 and Div 2, but B questions get difficult, and you're giving virtual contests of Div 2. Okay. So if you're giving virtual contests, that's very good. Make sure that after you do your virtual, next day you definitely absolve the problem which you didn't get. And if you feel like you're not making progress, then definitely, I feel a lot of people read the editorial too fast. So if you're the type who reads the editorial too fast, maybe spend more time thinking, right? A lot of progress depends on active thinking. So um, the the fact that you're struggling with the problem always pays off, right? Um, and basically what I'm trying to say is if you're getting always stuck in B questions, then you should practice a bunch of B questions, right? You do the VC. After the VC, if you're not able to solve the B question, you upsolve the B question. And while you're doing that, try to struggle as hard as possible, right? Even if you feel like you're not getting it. Because when you do that out of the contest, when you're in the contest, because you've done that struggle, it becomes pretty easy after a while. I had an OA with Deutsche Bank. People who didn't, so I'm not sure. I can't comment about your OA, right? Today is easy. Yeah, today is very direct questions. Okay, then, guys, I guess we handled a bunch of doubts, a decent amount. Let's just do one or two last questions and then wrap it up. Can I do CP in fourth year? I'm 1300 on CF. Why not? Your fourth year is just starting, right? So there's still some time to go. You can definitely grind. Govind, my profiles are there on TLE. You can go check them. You go to our mentors on TLE, eliminators.com/mentors. You can see my profile. This is me, okay? And my link to Codeforces and LinkedIn are both here, okay? To be honest, I can't answer my job-related doubts as I myself have not placed yet. So what I do know is that for every MNC or whatever company you want, you can go ask your seniors what type of questions are asked. That will be the best source of knowledge, I think. Yeah, Anshul, see, if you do dedicated and you know, like like very like basically when you do the practice, it should be intense. You should not be thinking of other things and you should be focused, right? So if your 4 hours are very focused, that's more than enough for CF. I myself am not, you know, that regular with my practice, even when I did uh, earlier. So, 4 hours enough if they're focused enough. Again, Anant, the main answer is practice. The second answer is ensuring that you learn the basic topics like binary search, DP, etc. So once you have the basic topics down, you can practice. If you don't have the basic topics down, first learn those, then you begin your practice. Okay, that's about it. That's the secret for almost any field, I guess. All right, then everyone, we're going to wrap up the session now. Thank you for attending. Hope you learned something. and best of luck to you all. Good night, everyone. Bye bye.